And so the second case is Babak. Babak, you're here. So you also came from Carnegie Mellon? Out of order, yes, okay. Okay, the floor is yours.
Yes. So great to be here after 20 years of HiPEAC. I don't know if Matteo remembers, but he introduced HiPEAC at the ISCA business meeting. Don't remember what year that was, maybe it was 2005. And I'd never heard, I've actually lived in Europe. I lived in Germany as a teenager. It's like, there's computer architecture in Europe, that there's something cooking. So that looked really good. Very good presentation. Now, 20 years after, we see the results of this. People have talked about a lot of accomplishments of HiPEAC. Two of them I can mention have received actual international recognition. So the highest service award in our community is the Berenbaum. Alan Berenbaum was a phenomenal person who was involved in ACM, computer architecture. We all knew him. He was the most approachable person for all young graduates, which was amazing at the time. And Kuhn received the service award for HiPEAC. This is international recognition in our community. And then Per received the Journal First Award for the recognitions of the publication system that Owner just talked about. Why is this Journal First model important? Our community is growing beyond the sort of numbers that we could even project a few years ago. It's not growing as fast as AI, but it's growing phenomenally fast, and our review models have not really changed. It's extremely difficult to introduce new reviewing models. I've been SIGART chair for 4 years. I'm now past chair, and our communities are also not very accepting of new ways of doing things. So the Journal First model really is a pioneer in our community to help address that. So that's just recognition. I'll just say one other story. So when I came here, I actually came in 2007 on sabbatical and stayed 2008. Came to HiPEAC. I was welcome. I wanted to work on the cloud. There was a lot of high-performance computing was super strong, and meta-computing was super strong, and the cloud was just emerging. And we'd also done at the time, we'd done work where we showed that chips are all power bound, and even though the NART scaling was still going, we weren't seeing the increase in the number of cores with Moore's law. So something was to give, and obviously we're power bound, and so what we do is every generation, instead of doubling the number of cores, we just pad them with caches. And we did some research, and this was basically Nikos Ardovelos' thesis, where we showed that we're just adding caches, we're out of power. HiPEAC was the place where we came together with Emre from ARM at the time. Emre brought in Nokia, brought in IMEC. We brought Janos on board. And we said, let's look at building a next generation cloud chip, cloud CPU. This was the first generation of cloud native CPUs at the time. And we showed that, well, you know, if you don't use these big cores, because you're power bound, you go to more efficient cores, you can actually turn a lot of that dark silicon into computing. And by the way, those cores also didn't really need as much memory bandwidth. And so that's one of the things that it was a big surprise at the beginning in the kickoff of the project, because IMEC was there to do 3D integration. We showed results that, you know, a lot of these workloads, they just don't need a memory bandwidth, so we're okay, even if we don't do 3D integration. We couldn't get ARM to be interested in this at the time. I mean, I know Emre was working really hard, and I think ARM knew something that we didn't know at the time. And that was that there were no software stacks in the cloud for ARM. So there was a whole bunch of companies that followed, that built ARM. So I think Paolo talked about Moonshot. There was, Qualcomm got into it, Samsung got into it. Everybody was building ARM chips at the time, but in the end, Cavium, which followed what we basically came up with in terms of sort of a solution, they all pivoted to HPC because they couldn't sell the cloud. There were no Linux stacks, there were no software ecosystem for the cloud. So those are the stories I remember. I think moving forward, look forward to another 20 years. I hope it's not going to be all AI. I think AI will probably slow down a little bit, but AI needs the cloud. And I think the next level of integration, because we're at the end of More, is rack scale integration. So I'm looking forward to seeing rack scale computing together with this community. So.
Thank you.